quadratic inequalities. To solve quadratic inequalities, the first thing we need to do is put the equation or the inequality in standard form. It'll be the same as the standard form for a quadratic equation, except you don't have the equal sign, you have a less than or greater than sign. So standard form simply means you have the 0 on one side of the inequality. Then we want to find the zeros of the function. Remember, the zeros of the function are where the function equals 0, or where the function has x-intercepts. Then we want to look at the graph, and we choose the x-intervals that give us the portion of the graph that we want. If your original problem had the function less than 0, then we want to look at the parts of the graph that are below the x-axis. If the function is greater than 0, then we want to look for the parts of the graph that are above the x-axis. So let's take a look at this problem. X squared plus 4x plus 3 equals 0. This is already in standard form. The first thing I want to do here is solve this for equal to 0. So solve it for my zeros. This particular problem I can solve by factoring. Remember the steps here. If you can factor it, you want to solve it by factoring. If it can be solved using the square root property, use that property. And if not, either use completing the square or the quadratic formula. So here we have the factors x plus 3 times x plus 1 equals 0. So we set each factor equal to 0. And this gives us zeros of x equal -3 and x equal -1. So these are kind of what I call my boundary points. They are going to serve as separation points that are very important on the graph. Now, let's look at the graph of the function x squared plus 4x plus 3. Now I want to use a standard window to begin with. A standard window will work fine for this graph. When I look at this graph, I can see my x-intercept right here and right here. This corresponds to the x of -3, and this corresponds to the x of -1. To solve this inequality, x squared plus 4x plus 3 less than or equal to 0, I want to know where my function has values that are less than or equal to 0. That means where my y values are less than or equal to 0. Well, that means where my graph is falling below the x-axis. So the only portion of my graph that's below the x-axis is right here. And this portion has x values that are between my -3 and my -1. So my solution here would be the interval where x goes from -3 to -1. Here I would include my endpoints because I have the equal mark with my inequality. Now I also want to look at the table for you to see that. If I want to look for where my y values are less than 0, in my table here I see that they're equal to 0 at -1 and -3. And where they're less than 0 are the points in between there. Anywhere else on the table, I have positive y values. And I can scroll forever there, and I'd still keep coming up with positive y values. So let's go back to the graph. And now, let's solve this inequality. X squared plus 4x plus 3 greater than 0. So this time, I want my y values greater than 0, which means I want to look at where the graph is above the x-axis, where the y values are positive. So that happens at what I call the tails of the graph, this portion and this portion. This portion of my graph corresponds to x values that are less than -3. So that would be from -infinity up to -3. And then the other portion of my graph corresponds with x values that are bigger than -1. So here I have a compound statement for my solution. Well, now let's look at this one. Y squared minus 2y is minus 6 is equal to 0. So again, I can solve this. Can I solve this by factoring? Let's see. Can I find numbers that multiply together to give me -6, that add together to give me -2? I don't think I can do that here. So if you can't factor it, you are either going to use the quadratic formula or completing the square. So I'm going to use the quadratic formula. A is 1, B is -2, and C is -6. So my y would equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So y is the opposite of a -2 is a +2 plus or minus the square root of -2 squared minus 4 times 1 times -6 all over 2 times 1. So this will give me y equals 2 plus or minus the square root of, let's see, this is going to be 4 plus 24 is 28. So I have 2 plus or minus the square root of 28 over 2. Now I want to simplify my radical because 28 is 4 times 7. I can take the square root of the 4 to get a 2 and leave the 7 under the radical. And then, let me move my calculator over. I can factor my 2 out to get 1 plus or minus square root of 7. 2 times 1 plus or minus square root of 7 over 2. So my x-intercepts occur when x is 1 plus or minus the square root of 7. Now, let's look at the graph. X squared minus 2y, or 2x, minus 6. Here's one of the x-intercepts, so this would be the 1 minus the square root of 7. And here's the other one, 1 plus the square root of 7. If I want the part of the graph that's less than 0, I want the part that's below the x-axis. So that's going to be the part that's between those two x-intercepts. So my solution would start at 1 minus the square root of 7, and it would end at 1 plus the square root of 7. If I want the part of the graph that's greater than 0, I want the part that's above the x-axis. So here that's going to be the ends of the graph. So the first end, or the first tail, is going to correspond with x values from negative infinity up to 1 minus the square root of 7. And I'm going to union that with the other interval, which would start at 1 plus the square root of 7, and go up to infinity. None of these would include the end values because I don't have the equal part marked here. Let's look at one more here. This one I can solve by factoring. This would be y minus 1 times y minus 1. So the only x-intercept I get is y equals 1. So let's look at what that means on my graph. I have x squared minus 2x plus 1. See where it touches the x-axis, but it certainly does not go through. So let's look at this problem. I want to know where y squared minus 2y plus 1 is less than 0. That means where it goes below the x-axis. If I look at this graph, there's not any part of this that's below the x-axis. My y values are never going to be less than 0. So I would say there is no solution to this inequality because it is never below the x-axis. Now, if I had y squared minus 2y plus 1 less than or equal to 0, I would have a solution there because equal to 0 is your x-intercept. It's where it touches the x-axis. I would only have one solution, a y value of 1, but I would have a solution to that one. Now, if I look here, I want to know where my graph is above the x-axis, not including the x-axis, just above the x-axis. And it is above the x-axis everywhere except that one place where it touches the x-axis. So it's going to be above the x-axis for x's that go from negative infinity up to 1, don't include the 1, and then from 1 to positive infinity. Or in other words, everywhere that x does not equal 1, or y, I guess, is not equal to 1.